Hey everyone, I'm going to make a quick video talking about relative velocity since a lot of you have had questions about one of the pre-lecture reading quiz questions. So the relative, let's say you have three objects. You have an object A, object B, and object C. Then the velocity of object A in relation to, so relative to object C, can be found by taking the velocity of A relative to B and adding that to the velocity of B relative to C. Note that each of these terms is a vector. So this is a vector sum equation. So you can't just add this number to this number and expect to get velocity of A relative to C. You need to add this vector to this vector. This can be done either using geometrical vector sum, or it can be done by finding the components, the I and j components of vector A relative to B, and then the components of B relative to C, and adding it that way. A shorthand of this equation, you can just drop this word relative in each, or the abbreviation of relative, and you can write it as VAC is VAB plus VBC. Let's take a look at an example of this. So let's say we have an airplane that is heading north in the air at some speed, and there's wind flow in the southwest direction at some speed. How do we determine the velocity of the plane relative to the ground? By the way, this is an example with just, it says some speed. It actually doesn't give us what the speed is. So we would just come up with the with a expression for how you would calculate the velocity of the plane relative to the ground. So first, let's identify our three things that everything is relative to. So we have an airplane. So that's one of the objects. We have, there's the air, so object B can be the wind. And then our third object, so it's kind of odd to call them objects, but basically things that, the reference frames that everything is in relation to. And our reference frame C could be the ground. So when we say an airplane is heading north in the air at some speed, well, the airplane's in the air, so its speed is relative to the air speed, which is the wind speed. So the first piece of information is V airplane relative to the wind. So that would be the first vector. And let's work in a coordinate system where north is the y direction and east is the positive x direction. So in that case, we would write that this is some speed. We can just call that VAW, let's say, and that's going to be in the j hat direction. Then we have wind flow in the southwest direction at some speed. So that is going to be the vector, the velocity vector for the wind relative to the ground, because usually wind speeds are measured relative to the stationary ground. And we can call this some VWG in the, so now we need a direction for this. So since it's going in the southwest direction, actually we'll have x and y components for wind relative to ground. So let's draw wind relative to ground. That's basically this vector here. And since they're telling us that it's in the southwest direction, so the southwest direction basically makes an angle of 45 degrees here because it's halfway between south and between west. And there's some speed v wind relative to the ground. Now the two components of this can be written as VWG cosine of 45 degrees. Now the x component, notice, is in the negative direction. So that's going to be negative minus 1 times the speed of the wind times cosine of 45 degrees. And this is in the I hat direction. Plus, or actually minus, because the y component is in the southern direction, which in our coordinate system is negative y. So minus VWG sine of 45 degrees in the j hat direction. So if I would like to know the velocity of the plane relative to the ground, so what we're trying to find is velocity of the airplane relative to the ground, we would need to take the velocity of the airplane relative to the wind plus the velocity of the wind relative to the ground, and add these two vectors. So pretty much I need to add this vector here, which is A relative to W, to this vector here, which happens to be W relative to the ground. And if I do this vector sum, I would get the velocity of the airplane relative to the ground. Now, we don't have numbers for all of this. In your reading quiz, the example is actually simpler than this. It's still a two-dimensional example, but the setup is a lot simpler than this. And I can just verbally tell you the setup is you have a train that is moving at some speed. So let's say the train's moving this way, and then there's a person inside the train who tosses a potato perpendicular to the direction of the train, so that can just be in the upward direction. So relative to the train, the person tosses the potato upward. You know how fast the train's moving relative to the ground. What you're trying to find is the speed of the velocity of the potato relative to the ground. So let's say somebody else is standing here on the ground and observing this. How would they measure the speed? So that's pretty much what you're trying to find. I hope this helps you with the problem.